Hey, Vlad here, devincited.com. Welcome to another video. In the previous few videos, we talked a lot about implicits and type classes, and I was planning to make a video where we would take the type classes and sprinkle them all over our collections library to put them into practice, so to say. But then I realized that we were missing something worth discussing. No secrets this time though. We're going to talk about the generalized type constraints and the relationship between type classes and views. Let's do this. As always, we're in the Ubuntu virtual machine and we're running Sublime Text, the editor of my choosing, fully maximized with a wonderful plugin called Terminus, which we have here at the bottom, which emulates the entire terminal, which we use to run SPT, which reruns the test every time we save the file. So we're back in our Homegrown collections project, and the first thing that we will do is we're going to start using simulacrum, which is a library and a compiler plugin, which generates some boilerplate around our type classes. The plugin is absolutely optional. In fact, we're not going to use it much ourselves, but I figured since it's been quite heavily used by the functional part of the Scala world, it might not be such a horrible idea to introduce it. The first thing that we will do is we will open our build SBT down there. Simulacrum already depends on a higher version of Scala, and I didn't want to update it until it's necessary, so we're going to do it right here. So it's 2.12.8. I believe Simulacrum relies on 2.12.7, so if we're already updating the version, why not do it completely? So at the moment of this recording, this is the latest version, and if you're not familiar with semantic versioning, this number means that this is just a maintenance release, so it's just bug fixes, so it's usually very, very safe to upgrade it, and if you have any issues with that, it's super easy to downgrade it back again. What we'll also do is we will finally update SBT. We don't really need it, and usually you shouldn't touch the running system, but I figured that we haven't touched it for such a long time, so if we're already updating versions, then we might as well update SBT, and it's always a good idea to clean the entire project, and if you don't do that, then make sure that you delete the so if you don't do that and you run into issues, then make sure to manually delete the target folder, the project/target folder, and the project target folders. Okay, so I already cleaned, so we can exit it now. So we're going to go to build properties over here, and we're going to use the version 1.2.8, which is the latest one at the moment of this recording. So I'm gonna run SPT, and I have already downloaded it, so it's gonna go fast. But if you haven't, it's gonna take forever. It's gonna take easily like 10 minutes. It depends on where you are, obviously. So make sure to have some time. Now, as you can see, semantic versioning is applying over here as well. You see 1.2.8, so this version changed, which means that this is a major release. So there are major new features, and if you have a bigger project, then you might run into issues. Maybe some plugins are not supported anymore. But in our tiny project, we shouldn't run into any issues whatsoever. Now, SPT introduced a new feature called server, but we're not going to use it. So what we're going to do is we're going to go to build SPT and add somewhere a line which says auto start server equals false, like this. And if we reload SPT, then the server will not be started. Okay, and we'll also see there may be incompatibilities among your library dependencies. Run evicted to see the detailed eviction warnings. Well, let's see that. Evicted, nothing. Okay, well, I guess we can pretty much ignore it. Okay, so we shut down SPT, and so the server was also shut down. So if we start SPT again, then it should start without the server. All right, so now we can actually start adding simulacrum. Let me collapse the sidebar like this. So we're going to go into our library dependencies over here, and I'm going to create some more space like this. So we're just going to go down here, and we're going to add a dependency to com.github.mpil quest. I have no idea how to pronounce that, and we're going to say simulacrum like this, and the latest version as of right now is 0.15.0. Simulacrum relies on a compiler plugin, so I'm just going to add a compiler plugin over here. Okay, so it's in org.scala macros. Let me scroll down a little bit like that. Okay, and it's like that. I'm sorry, like that, and it's a Paradise, and the version is 2.1.0. Now we need to specify over here that the version that should be taken is the full version. This is supposed to say cross version. Let me explain this to you real quick. So if we leave this out, right, then the jar that will be looked up is going to be called Paradise underscore 2.1.0, like this. I'm sorry, not underscore, it's actually a hyphen, like this. Okay, and this is a short syntax for cross version dot disabled, right? So this is the same thing, like with or without it. Okay, then if you do that, then this is the same. I'm sorry, if you do that, okay, then this is the same as doing that and saying that the cross version is going to be binary. Notice that the b is small. Okay, binary means that the jar that will be looked up is going to be 212 hyphen 2.10 212 because we're using over here Scala 212. Okay, and the last one is this one, the full one, means that the jar that will be looked up is not only 212, it is actually 212.8 because we're using, you know, the full version 212.8. Okay, so this was just a tiny crash course. This is why we need this. Okay, cross version dot full, and I believe this is all that we need. So we can reload SBT, or you can just shut it down and start it again. And I already have the plugin downloaded, but it's going to be downloaded for you, so it's going to take a bit more time. Let me just run the test. It's the first time that it's running was SBT 128. All right, so the first thing that we're going to do is we're going to have a tiny example of Typeclasses again. So let me create a file, get some rendering issues over here. So I want to go into Homegrown Collections, source, main Scala, Homegrown Collections, okay? And let's create a file called typeclasses.scala, okay? And we're going to go and just create a main, object main, extends app like this, and we're going to print out my favorite hyphens to 500 times 50 again like this, and we're going to print out hello world like that. I'm going to switch to running this main, so we're going to say run main, okay, like this. So we're running our hello world. I'm going to copy my favorite hyphen, I'm going to paste it over here because I don't like to have these Unicode characters over there. All right, so we got our hello world project. So the first thing that we're going to do is we're just going to create a type class example. So we're going to have a trait, we're going to say some type class, okay, like this, because I want to show you what simulacrum actually generates, what it's actually doing. Okay, so it's actually not that much, but it is actually a lot if you're using type classes a lot. Okay, so we're gonna have our type class, and we're gonna have some instance for ints. It's gonna be some type class of int, and it's going to be, we're gonna use samtype expansion like this, console.yellow plus the number that comes in plus console.reset, just an example. Okay, and then we're going to have an algorithm which is defined for some t which needs an instance of the some type class. Okay, and it gets the t, produces a unit because this is just an example. All it's doing is going to print out. Then we're going to retrieve the instance by using the implicitly function which is defined in printf. We're going to say implicitly subtype class for t. Now we have the instance, and then we can call functions on it. What does it have? It has do it, and we're passing in the t. And this is how we can use it. We're going to say algorithm of 10. And in fact, maybe I can create some more space over here. All right, like that, so we can actually see the entire example. So now if you want to use simulacrum, all we need to do is we need to import simulacrum like this. And now we have an annotation, which is called type class. So we can just annotate our type class like this, and what it will do is it will generate a companion object and a few other things. And in this companion object, we will be able to do something like this. So instead of implicitly some type class of t, we will be able to say some type class of t, just like that, and then we can just call do it on it, right? So it's going to be exactly the same thing. So if I type correctly, then everything will be fine. Okay, so we see the 10 twice now because it's been printed out twice. So it's generating a function that is much, that allows you to retrieve the instance with a more convenient syntax. And also, if you add an import to this companion object .ops, there's another object .ops inside of this companion object, then you can also do a print line t. So if you have already a t, then on that t you can call type class instance, right? And then you can call do it, which is actually a bit longer even than this syntax. All right, so that is all I wanted to show you. In fact, I'm going to go and delete this file because we don't really need it. Type classes, I'm just going to delete that, and I'm going to switch to running tests again over here. Okay, let me collapse that. So we're going to go to set suite, and we're going to find the test for a flat map. So if I search for flat map, so what we're going to do is we're going to copy that test just like that. Gonna paste it again over here. I'm just gonna call it flat map because I don't really know what to call it. So we're gonna work with this test, but we're gonna minimize it a little bit. So let's just have only A, B, and let's have only 1 and 2. So if you remember this test, it was just generating a chessboard was using by using the flat map method. Okay, so what we're gonna do now is we're gonna say chessboard should be set. So this is like a partial chessboard. So let's call it partial chessboard. Okay, so let's call it partial a partial chessboard. So what it should be now is it's just a set of A mapped to 1. So this is just a tuple, okay, and then to 2. Then we're going to have B1, and we're going to have B2, just like that, okay? Let's see, there's a warning because Clariform does not know how to deal with these commas, okay? All right, so it's green again. So what we're trying to do today is we're trying to make our collections library work together with the standard collections library. So if we go to numbers and we change this to a list, okay, then it should just work, but it's not going to work because it's going to say, hey, flat map wants a foldable of this tuple, but you're giving it a list. So what we're going to do now is we're going to open the foldable factory where flat map is defined, okay, and we're going to look at the signature. So the signature says, okay, I want a function that takes the element and maps it to a foldable of result, and foldable comes from our collections library. And why does it need a foldable? Well, because it calls fold. So if you go to foldable like this, then we're going to see, okay, it needs fold. This is all it needs. So notice that we also have the issue the other way around. So if we were to start with the list from the standard library, and the second one would be our set like this. So if I switch them, right, so if these are lists and this one is a set, then we will see a very similar message, right? But it's going to say, hey, you're giving us a set from your collections library, but we want a gen traversable once. Okay, so we have the issue the other way around as well. But for now, let's revert it back to our sets, so that everything just compiles. And we're also going to switch to compiling, and we're going to see how we can solve this entire issue. Now, an object-oriented solution would be to mix these hierarchies together, right? So we'll take the list, we will go and see what is at the top of the hierarchy for that list. And as we've just seen, it's gen traversable once. And a quick note, we don't need to actually go as high. It's enough to go to traversable. So we're going to work with traversables today, okay? So let's pretend that traversable is at the top of the standard library hierarchy. And we're going to look at our sets, and we're going to do the same thing. We're going to go to the top of the hierarchy. Technically, we're actually going to look for fold, and we're going to see what's at the top of the fold hierarchy, but foldable hierarchy. But foldable seems to be at the top of the hierarchy, okay? And then you will try to mix them together. In our case, we'll try to make foldable actually extend traversable. So let's try to do that. I'm going to extend traversable like this of element like that. Okay, so let me save this file. Okay, it's going to say, okay, 4 errors found. Okay, it says you need an override modifier on the group by. So the problem is that group by is actually already defined in traversable, so we can pretty much just comment it out like this. Okay, same thing for all. Okay, for all, let's just comment it out, same signature. Okay, same thing for exists over here. Let's just comment it out, same signature. Okay, the same thing for the size. Okay, let's just comment it out, same signature. Okay, this one seems to be different. Let's look at it. Oh, it says name clash between inherited members. And this is a very, very typical issue for object orientation, that these hierarchies are very, very fragile. So we ended up having a name clash because in traversable, there's also a method called fold, in particular this one, which is it's similar to our fold, but it's not exactly the same. So it's constrained a bit more. So it can only fold the same type. So if you have a list of integers, then you can fold and produce only an integer, right? Or technically a super type of integer, but there is no super type of integer. I mean, you know what I'm saying, right? So basically the method is doing something different, and we have a choice. What we can do is we can rename ours just so that we avoid this name clash, right? But then we will have to fix all of our tests, which are broken now. And if our tests are broken, this means that our user code is broken. And we really should avoid that as much as possible. So basically it means that the solution is not going to work for us. So basically adapters or type classes are going to come to the rescue. First of all, let me revert that back. Okay, like that. We're not trying to extend traversable like this. It's all good again. Let me scroll down over here. So the first few solutions that I'm going to show you are not going to be the proper ones. So I occasionally make videos like this where we sort of walk into the proper solutions sort of backwards. So we try like really nasty things that really don't fit, because as I said in the beginning, I really wanted to make a video where we're going to start using type classes. And when I was preparing for this one, I started using type classes everywhere. And then I noticed that they're just not the right tool for the job. So I'm going to make the same mistakes for you so that you don't have to repeat them. So we're going to start with type classes, and we're going to notice that they're not the right tool for the job. All right, so let's go to Foldable Factory and look at flat map and realize again why it needs foldable. It needs foldable because it needs fold. So if we create an adapter that just has something like fold, then it should be fine. So what we're going to do is we're going to go into, so we have trait foldable. We're going to create a companion object over here. Foldable, okay? And we're going to create a type class. So we're going to use a simulacrum over here, simulacrum like this. We're going to create a type class, right? Type class. We're just going to call it type class, and then when our users are going to use it, they're going to say foldable.type class, and it's going to look really cool. Okay, so it's the first time that we're having a type class, not just for some t, which we're going to call af today, but the af is going to be of a higher kind. Okay, so it's not going to be anything special about it, so don't worry. Okay, so this is just going to be this type class, and it's going to have fold. And you know what I'm going to do? I'm going to go to the trait foldable, and I'm just going to copy this line. Okay, and I'm going to paste that down over here just so that we have some sort of template. So we're not going to use this one, but we're going to use a similar one. Okay, so we're going to have a fold, and notice that we don't have element specified anywhere over here. We had it over there. So over here the element will be part of that signature or fold, and the rest is going to stay pretty much the same. It's going to be result, and it's going to have the same thing. It's going to have the seed was the result, and it's going to have the function that will take the result, take the element, produce the result, and the whole thing is going to produce the result. The only thing that is missing is actually the instance of this af. Okay, so we also need that, and we're going to pass it to fold. So we're going to abuse this first parameter list, and we're going to say, okay, af is going to come in of type af of element, like this. Okay, so this is why we need the af over here, we need the element over here, we marry them together over here. So this is our type class. So if we want to have instances of this type class, then we need to implement fold with this signature. We could also keep going actually and implement all the other methods in terms of fold, but as we have seen in the foldable factory, it only needs the fold itself. Okay, so we're just going to save that and see if I made some typos anywhere. No, I didn't. Also notice that because we're working with foldable, and foldable is at the top of the hierarchy, and the incremental compiler is killing itself because it basically needs to recompile almost everything. Well, not everything, but you know, a lot of stuff. So we're going to go to foldable factory now. We're going to go to flat map, and we're going to make it use foldable.type class instead of foldable directly. So we have this flat map over here, and we're going to say, okay, so this is not going to be just a result. This is also going to be some f, right? And this f is going to be needing a type class, foldable.type class. This is why I created the object and put the type class inside of it so that it looks cool like this. And then it's going to have a function that takes an element, but it doesn't produce a foldable result. It's producing an f of this result. Okay, and then we're going to use simulacrum to retrieve the instance of this type class. So we're going to go foldable.type class, you know, give us the instance for f, and we're going to go fold on it, right? And fold, the first thing that it needs the actual foldable. And how do we retrieve the foldable? It needs an f, and this function can give us an f. Okay, so this is going to be function of current. So this thing goes in there, and we're already calling fold, so we don't need that. And we decided to put the accumulation and the function in the same parameter list. So there's going to be a comma over here, right? So this is exactly how we define the fold. We said, okay, give us this f and the accumulator, and then give us the function. Let's look at it again over here. Give us the f, give us the seed, and then give us the function. Okay. Also remember that we have a wrapper over here that also has a flat map, but we're going to fix it later. This wrapper was necessary to have the if inside of for comprehensions, and we might touch on that a bit later in the video. All right, it looks like everything is compiling. You know, it was super easy to do. Let's write our test. Sorry, not write our test. Let's run our test, and we're going to see that sets are not compiling anymore. Basically, I mean the test for the set. Okay, so it's going to say couldn't find implicit value for evidence parameter of type Homegrown collections foldable type class for sets when we're trying to create those chessboards. So what we're going to do is we're going to open set. And we're going to go to the companion object, which is a good place to put your instances. And we're going to create an instance. Okay, so we're going to say, okay, so this is going to be an implicit val. Let me scroll down a little bit. It's going to be a foldable instance, right? It's going to be foldable dot type class for sets this time. Okay, remember it needs a higher kinded f, and set is a type of a higher kinded. It's a set of element. Where did the sun go? Sun, come back. All right, so this is going to be, we're not going to be able to use SAM extension test because our parameters are sort of spread out all over the place. So we're going to say new foldable dot type class. So we're going to use anonymous classes. Oh, the sun is coming back. All right, so we're going to have that like this, and over here we're going to override def, and I'm just going to copy that. So we're going to go to foldable, and I'm just going to copy that entire thing. I'm going to paste it over here, and now this f is just going to be set. okay? And the implementation is going to be like that. It's just a stupid delegation to the set fold, seed, and function. That is all that we need. It's marked as implicit, so the instance is going to be picked up, and I call it F like this. Okay, so now everything should compile, the test should be green, and everything should be fine. Now the problem right now is that we're having is that now we can only do this for sets. So if we try, for example, to convert this to maps, in fact, let me create some more space. I'm going to create another one so that we have this other one not ruined. I'm just going to have map here. I'm going to remove it in just a second. Okay, so let's say that this one is not going to be a set. This is going to be a map of 1 to Roman 1 and 2 to Roman 2. Okay, so what is going to be produced here is not going to be an integer. It's going to be a tuple of integer and strings now. Okay, and the set that is going to be produced is going to look like that. Okay, so if I did everything right, then it's not going to compile because it's going to say, hey, we have an instance for the sets, but we don't have an instance for the map. In fact, over here, it's going to say we don't have an instance for foldable. So what we're going to do is we're just going to go into here and we're going to cut out the entire instance, right? So now the sets are also not going to work. We're going to go back to foldable, and we're just going to add an instance over here. I'm going to add it over here, and we're going to say that this is a foldable. I'm going to call it foldable type class instance. Now it's not for sets, it's for foldable, and I'm also going to call it from Homegrown collections library like this. And I'm doing this to avoid accidental shadowing. Okay, so this is going to be a foldable type class, not for set. It's going to be a foldable type class for foldable. Okay, so foldable over here, foldable over here, foldable over here, and let's see, scroll down. Okay, it's the same thing. Now it doesn't compile because remember in the previous video actually I showed you that if we're passing a set and we're saying that an instance of foldable should be enough because foldable is higher, and the way to solve this, because we have two kinds of ad hoc polymorphism. We have type classes and we have subtype polymorphism, and they're stepping on each other's feet. And I told you that there are 3 possible ways to solve this. And in our case, because we have control over our type class, because it's our type class, we can go into it and we can say that this app is going to be contravariant. This tiny minus is going to help us resolve all of these issues. And in fact, I don't really need this comment. Okay, so let's remove this comment. Okay, now at least it compiles. Now it says 1 test failed, which means that I typed something wrong. I actually already see what I typed wrong. Okay, I actually completely forgot the Roman literals. Okay, so we're going to go over here. I'm going to say, so this is not just a 2. This is actually a tuple that takes a 2 and produces a 2. I'm sort of talking about tuples as if they were functions like this. And by the way, these ones, let me scroll down first and see that it's actually working now. Come on, everything seems to be green. All right, everything is green. Let me save again just so we're sure. Okay, so everything is green. By the way, these ones are gone because this one is a map. So when it adds the A1 to the map, everything is fine. But then when it adds A was a key of 2, it just overrides this one. So this is why these ones are gone. It was actually a bit surprising for me when I was preparing for this video. Let me comment this out, and let's go back to our original problem. And we're gonna say that we want to have a list over here, right? And it's not gonna compile, for the same thing, for the same reason, because now it says, hey, I need an evidence parameter for type class of list. Now we could define an instance for list, but we already know that traversable is at the top of the hierarchy, so we might as well define an instance for traversable. And note that foldable is not involved over here right now, okay? So we can't just put it over here, right? We need to put it somewhere where so we need to put it either into the traversable companion object, which we don't have access to, or we need to put it into the type class companion object. So we're going to have an object type class over here, right? And inside of it, we're going to have an instance. Let me copy the name over here. Okay, so I'm going to have, in fact, let's copy the entire thing. Let's copy the entire thing, put it over here, and let's call it foldable type class instance for traversable. Okay, in fact, everywhere where we say, no, not like this. Okay, traversable, like that. Let me comment that. Not comment, let me mark that, copy that, and let's see, type class for traversable, and traversable actually has a method called fold left, which looks exactly the same. I believe it's actually fine. Yeah, so all our tests are green now. So this is all that we need to do. So we have an instance for foldable and we have an instance for traversable, and everything works like a charm. In fact, not everything works like a charm because we only solved it partially. We only solved it for our side of the problem. But if we switch it like that, so if we say that this is going to be a list and this one is going to be a set, then it's not going to compile because the collections library is not prepared for type classes. It's not prepared. It doesn't say, hey, give me some type class instance. It really wants you to give it a subtype of gen traversable once or simply traversable, right? And there's nothing we can do to make it happen unless we define an implicit conversion that will take all of our foldables and convert them into traversables. In fact, this is the correct solution, and we're going to do this by the end of the video. But now we're going to leave this problem alone, and we're going to look at something else. It's going to be related, and we're going to come back to everything. Yeah, it's not actually exactly this thing. It's going to be an entire different function, and it's called flatten. And this is the first time that we're introducing flatten. So I'm just going to go here. I'm going to say flatten over here. Right. By the way, let me revert the code a bit so that it compiles now. I want everything to compile. So this is going to be a set, and this is going to be a list. Okay. So now in flatten, I'm going to use the sets from predef because our sets don't have this method yet. So we're going to say predef.set. Okay, and we're going to have a predef.set of 1 to 3, and then we're going to have okay, actually this is not faster. 4, 5, 6. And we're going to have 7, 8, 9. Okay, let's remove this column. Okay, so if we call flatten on that, so flatten is designed for nested structures, right? So if you have a set of sets, you call flatten on it, it's going to flatten both of these sets into one. So it's just going to do set 1, 2, 3, 4, 5, 6, 7, 8, 9, I believe, like that. So it's not going to be a set, it's going to be a predef.set like this. Okay, let's see. Actually, forgot to say should be like that. Okay, so we have a nested structure, we flatten it out. Now at this moment I really want you to take a minute and try to figure out how set is defined in the standard library, right? Because the set, it wants, it's parameterized with some type. Okay, so over here it's going to be a set of sets of ints, right? And this one is going to be a set of ints. Okay, let me compile this. I should probably say predef over here, predef like this. Okay. Right, so these are the types. Now think about how set is defined in the standard library. It has some parameter, right? Let's say that it's called element, the same as we called our element over here, right? So it's going to look something like this. It's going to be a set with some parameter called element. Now, if the element is constrained to be some sort of traversable, then we wouldn't be able to create a set of ints because ints are not traversable. If it is not constrained to be traversable, then how in the hell does it know that the things that we're passing in are something that can be traversed? Because this is what it's doing. Inside of it, it folds through them or for eaches over them, right? And it knows that it needs to take like all of these, 1 to 3 and put them into this bigger set. How does it know? And no, it doesn't pattern match on them. Now, the answer to this are a slight variation on view bounds or views in general, the ones that I showed you a few videos ago. And I think it was in the video, in the first video about type classes. Okay. Now, flatten has an extra parameter, which is called implicit, an extra parameter list, which takes a function that takes the type of element, whatever it is, and produces a traversable, or technically a gen traversable once, right? So basically once a view, it says, okay, if you know how to convert my type parameter into something that I can traverse, then I'm going to compile. Now, this is the proper solution, and this is the one that we're going to implement for our collections library as well. But as I said, first we're going to try to squeeze type classes into this. So we're going to go into foldable factory, actually, where we have our flat map defined over here. Let me create some more space, and we're going to try to define flatten, and it's not going to work. Okay, so we're going to have flatten, and we're going to say, okay, so flatten is going to be parameters with the result, because what it produces is going to be a subtype of foldable factory of result. Okay, so we have a subtype of foldable factory with element, and we want to produce a subtype of foldable factory of something else, hopefully a flattened structure. Now it's going to start the same as flat map is starting, so we're going to just duplicate this line. Okay, and I'm going to have an equal sign over here. I'm going to close that. Okay, so what is it going to do? Well, it's going to try to take this current thing, which is inside, right? So this is, this is the element, right? This is the element. And, it needs to assume that it is traversable and therefore that it has fold, right? Or technically, fold left in the standard collections library. Okay, so it wants to do something like this. It wants to do fold, start with an ACC, okay, and then just add them all together, right? Add them all together like this. Let me remove that element over here. Okay. Now, if you try to compile that, it's going to say value fold is not a member of type parameter element. Well, obviously, it doesn't know what this element is. This is called a universal quantifier, right? So this parameter, because it's not constrained to be anything, so if we go up, it just needs to be an element. So it can be absolutely anything. And it says that every method is going to work for absolutely any type that you're going to put in there. Okay, but this also means that this absolute any type, you can't make any assumptions about, right? You can't just assume that it's going to have the method fold, because it can be literally any type. It can be a string, it can be an int, it can be anything, a dog, a person, anything. Well, okay, what's the big deal? We're just going to request a type class instance. Okay, so we're going to have parameter list over here. We're going to try to have an implicit instance over here. We're not using the same syntax as we're using over here because it's not going to work anyway. Okay, so we're going to say, okay, so we're going to need an instance of foldable.type class for for foldable, right? Because we need to fold. Okay, let's try that, and then we can say, okay, so now we have the instance, so now we can do instance.fold, and then we can pass it the current, we can pass it the ACC, similar as we're doing in flatmap. Okay, and this should work somehow, right? But it's not going to work, right? It says type mismatch. I found an element, but I wanted a foldable of something, because we don't even know what the foldable of something is, right? So it seems that what we need to do is we need to somehow teach it about the fact that there is also an element in there, and there is also a result involved somehow into this, maybe like that, right? So I'm sorry, like that, right? But none of that is going to work because type class is parameterized only with one hold. There's only one thing that we can put in there, right? So if we go into foldable, there's only one thing that we can put in there. It needs to be of a higher kind, but it's just like one thing. So if we try to put like foldable result, then first of all, the element is not involved anymore, and also this is not a type of a higher kind, right? So foldable would be like this, right? But then we're back to the original problem. So basically this approach with the type classes doesn't really work for us. Or does it? What if we had a type class with multiple parameters? This is the first time that we have something like this. So let's call it not foldable.type class, let's call it multi-parameter type class, and it doesn't have anything to do with foldable actually. So we're going to have multi-parameter type class, right? So we're going to put it somewhere else in just a second, and then it will take the element and it will take the foldable of result like this, and then it's going to have an instance, right? So on it, it's going to have a method called convert that we can pass in the current, right? And then it's going to have the method called fold. Okay, so basically we're getting closer to the view solution with the view, but we're still trying to squeeze in type classes into that. Okay, so what we're going to do is we're going to create an entire new file. I'm going to save it. I'm going to call it multi-parameter type class. That's called. Okay, we're actually going to remove it by the end of the video. Okay, so it's still going to be in the homegrown collections library. Okay, and it's going to look like this. It's going to be called multi-parameter type class. Okay, it's going to have two parameters, from and to, and notice that both of them are of kind 0. Okay, so passing in this of kind 0 is fine, and passing in this of kind 0 is fine as well. And I'm going to say something to the variance in a second, but all you need to know for now is that it is contravariant for the same reasons that f was contravariant in our type class. Where is it? Over here, for the same reasons, right? Ignore the covariance over here first. So it's going to have a method called convert, right? Very simple one. Convert, from comes in, okay, and to comes out. And now we have it. We have our type classes. Everything is fine. Let's go to our test and actually test this out. So it works with predef. It probably should work for our sets as well. Okay, so if we paste that in everywhere where it says predef dot, I'm just going to go and mark them all, remove them like this. Let's see if it works. And it doesn't. It says couldn't find implicit value for parameter instance, multi-parameter type class, for foldable of result. So what we're going to do is we're going to go and create an instance for identity, right? Because set is already a foldable, so we're going to say, okay, there should be an instance for foldable. You know, if it's already foldable, then there should be an instance. So we're going to create an object over here, multi-parameter type class. We're going to have an implicit def. We're going to say view for identity from homegrown collections library. Some sort of t comes in, multi-parameter type class for t, and t comes out, right? So it should be possible to convert a t into a t because it's already a t, okay? So this instance should be available at all times, and notice that, again, it has nothing to do with foldable at this moment, okay? So just going to create a new multi-parameter type class for t, and we're going to say that it's going to define like this: convert tt and t equals t. Okay, so t comes in, t comes out. In fact, maybe it was possible to use just a identity function over here. Yeah, it is. So the identity function is doing exactly that, right? So something comes in, the same thing comes out. This is the identity function. Because this is a single abstract method type, the Scala compiler is going to convert this identity into this because we specified the type. Okay. All right. What about the same thing that we were doing with flatmap? Let's try to mix them. So let's copy that. Okay. Paste that over here, and let's say that this is going to be a list. Okay, so it doesn't matter that the list is inside. If we flatten set and list together, then the set should still come out. Now we're getting a type mismatch. Okay, actually I was kind of hoping that we would get a a type class is missing kind of thing. Well, okay, I guess it's fine. So the next instance that we're going to define is going to look something like this, but it's going to be gigantic, and we're going to put it right above the test. Okay, so you should still see like a little bit over here. Okay, so we're going to go right over here, and we're going to define a gigantic instance for traversables to work. So it's going to look like this. We're going to call it implicit def view from traversable, right? So this is the list, right? So if we can convert it to foldable from Homegrown collections library like this, some element comes in. Okay, so what we're gonna produce is a multi-parameter type class of, okay, so we're gonna have a conversion from traversable element to a foldable element, right, like this. And we're gonna say this is a new, and we can't use the SAM extension over here, so we're going to use, in fact we actually can, we're going to use it in just a second, but for now I'm going to do just that. Okay, so we're going to have an anonymous class. Let me create even more space because this is just freaking gigantic. Okay, I'm going to define our convert over here, right? We say from traversable of element, and what comes out is a foldable of element, right? And what it will do is it will create another anonymous class for foldable, right? So it would create another foldable, okay, for element, okay, and over there it's going to have a final override def fold. In fact, this is also a final override def fold. Okay, some result, this is the original fold, right? This is not our type class fold. Okay, so the function comes in, it takes a result, result, come on, what's up, result and element, okay, and it produces a result. The entire fold also produces the result. Okay, so it's just going to say from, which is traversable. It's going to say fold left, seed comes in, function comes in. Okay, so unless I made some typo somewhere, maybe I did. Let's go up. It doesn't know anything about multi-parameter type class. That means that there's a typo somewhere. Okay, the P is capital. Okay, P is capital over here and over here as well. Let's see. Scroll down. It doesn't solve the issue. Did I forget to make it implicit? This is probably why the error message was different in the beginning. I'm stupid. That's because I was way too explicit with the types over here. Right. So this should be a list. In fact, I'm just going to remove it completely. Right. This is exactly why the error message was wrong, because I was too explicit with my types. Okay, so now everything works, and without that this instance it doesn't work, and the error message is going to be actually proper. It's going to say couldn't find implicit value for parameter, and so this is exactly the one that I was looking for before, but it wasn't there. All right, so we have this gigantic instance like this, and with this instance it works, but it's really horrible. So we're going to improve it in just a few seconds, but what I want to show you is basically that we encoded a type class for views, which are sort of there anyway. Okay, so the first thing that I'm going to do is I'm going to go to the multi-parameter type class, and I'm going to rename it. I'm going to call it can be viewed as, like this, and obviously a bunch of things that I'm going to compile, so probably over here and probably over here like that. Okay, just a rename. Okay, so now if we go to flatten, I remember, I mean, there are so many things in Scala that I just casually mention in some videos, and I sort of assume that you watched them, but you probably haven't. if a class or if some type has two parameters, then you can also write it with using an infix notation. Let me create some more space over here. So if I duplicate that line, what I'm writing over here, element can be viewed as foldable of result, like that. This is exactly the same line. So if I comment out this one, this is exactly the same line. Let me remove this one, right? So this is just another, it's called an infix notation for types, right? So an element can be viewed as foldable of result, right? So this reads much nicer. So let me save again. Now the Scala standard library already defines two classes that are very, very similar to this. So this can be viewed as, we used to have one, and it was called like this, right? We don't have it anymore because views are being deprecated, or at least the syntax is being deprecated. There are two left. There is one called like this, and there's one called like that, and we're going to take a look at them real quick right now. Okay, let me revert back to can be viewed as. So let me open my browser, and so we're in the code for predev for version 2.12.8, but it has been like this since forever. So this is a sealed abstract class, and it's called exactly like this. Okay, so it has hyphen from plus 2, so minus from plus 2, so it's contravariant covariant. It extends the function 1, and the problem with this is that, well, it's not a problem, it's intended that it is sealed. So we cannot just go and define instances for it. And the idea behind it is that it encodes the true subtype relationship between the type from and between the type to. Okay, so there is a singleton defined over here, and I believe this is only done as a performance optimization. So there's only one instance basically that's for any, right? So if any comes in, the same thing comes out, and then you have an implicit def $conforms, which is called $conforms. By the way, it used to be just conforms. Over here is deprecated for the same reason as I mentioned in the video about implicits, for accidental shadowing, right? Very, very evil thing. Okay, so what it's doing is, so this implicit conform says, okay, if you give me a type, then I'm going to make sure that it is a subtype of this. So it's basically, no, actually, that's not true. Conform says that a type is a subtype of itself. Okay, so basically, if there is a way to convert a from to, and there is always a way built into the compiler to convert a dog into an animal, right? It always knows, okay, dog is an animal, so it works like a charm. Ours is a bit more flexible. Before going to that, I'm going to explain to you this one as well. So this one it looks exactly the same, but the from is not contravariant and the to is not covariant. So it basically says it has to be exactly this type. So you can have, for example, your set of element, right? So the element can be anything that you want, and you can have inside of the set one method where you say, okay, this method is only going to work if the element is a dog, right? Or if the element is a string, not some subtype of dog, not some subtype of string, right? Exactly string. Okay, so ours is way more flexible. In fact, let me show you this. So ours is actually a bit different, because for ours we can define an instance for absolutely anything that we want. For example, we could have a set of let's just have just 1, 2, 3, and we should be able to call flatten on it if we define a proper instance. In fact, let's define a proper instance for it, just because we can, Let me create some more space. Let's go over here, and let's just for fun define an implicit def view from int to foldable from int produces a foldable of int, right? So how can we produce a foldable of ints out of an int? Well, simple. We're just going to create a new foldable, right? And we're going to say, sorry, what happened here? Not like that, not like that. Okay, so I'm going to steal the signature from fold over here, final override def fold. Where are we? Over there, like this. Let me just finish typing this real quick, but in fact I realized that it's actually not going to work yet. So all we need to do, instead of like folding through something, we just need to follow the types. We need to do some type Tetris, and we just need to call the function. Okay, what does what want? It wants the result. The only result that we have is a seed. Okay, and what else does it want? Well, it wants the element, and the only element that we have is an integer. In fact, this should be an integer. Okay, so the only integer that we have in this entire scope is from. Okay, so what does this function return? It returns a result. And what do we need? We need a result. Okay, so we're basically done. So if I compile this, it's still not going to work because it actually, I made a tiny mistake. It actually assumes the next iteration of our code. So what we can realize is that, in fact, let me comment this out real quick. Let me comment this out real quick, like that. There we go, everything compiles again. So we're going to leave this for just a few seconds, and we're going to go into and massage this entire thing. So I told you that we can't use the SAM expansion for both of these anonymous classes, but we actually can use it for this one, for the one that creates the new can be viewed as. So instead of this, we just need to say, okay, some from comes in and new foldable comes out, right? So this entire thing over here is just going to be from arrow to the right. Right, from comes in and foldable comes out. Okay, so I'm just going to remove that. So unless I did something stupid, no, I didn't. Okay, so we got rid of the first anonymous class. We got rid of the second one, I believe, because our types are spread out a little bit. So the element type is over here and the result type is over here. I don't believe that we can keep going like this. But the next thing that we're going to notice is that our type class, this multi-parameter type class, if we go back to the code that I showed you in pre-def, it actually extends a function from 2, and it turns out that we can do exactly the same thing, and this is, by the way, why the contravariance is there. So we can extend a function that takes a from and produces a 2. Now the function that takes a from and produces a 2, it has a method called apply, and apply will have the same signature as convert, so we actually don't need convert over there. So we can just do that. We can go back to the foldable factor and we say, hey, it's not called convert, it's called apply anymore. Because it's called apply, we just don't need it like this. Okay. And what we can do now is we can replace this with an arrow, right? So to convert it into a simple function, and our code simply works now because we're creating an instance of multiple parameter type class, but multiple parameter type class is a function, and what we have here is a function. And now we can actually go back to the code that I just introduced. This one was the flatten. It doesn't work without the instance, but it does work with this instance, unless I did something stupid again. But no, it actually does work. Okay, so now we know how to convert an int to a foldable of ints, right? So this is what we have here, how to convert an int to a foldable of something, and that's why it works. Now obviously I'm going to remove this stupid instance because this was just an example that this type class that we created, you know, this can be viewed as, is more flexible than the one that is in pre-def, right? So this one wants a strict subtype polymorphism relationship between the type from and to. This one wants the exact one, and ours just wants some conversion, right? So it's built off the conversion. So basically we encoded the entire conversion. In fact, if you realize this, if I'm going to reveal this in the sidebar, if I'm going to cut this out, the only place that we're using it is in the instance, right? In the instance over here that we actually don't need anymore. Okay, so this thing, we don't need it anymore. We just need a function that can take something and it can produce a foldable element. Let me create some more space over here, right? It is just a function, right, that takes a from, which is a traversable of element, right, like this, and what it produces is a foldable element, right? So if we just remove that, we just remove all of that stuff, right, like this. It's not really visible, like that. Okay, foldable foldable element. Okay, so it's doing like that, and I believe this is all we need. Okay, so now we just have a function, takes a traversable, produces a foldable. This is all that we need. It's a new foldable over here. Now, because this is the final version, we can actually cut it out like that, and we can put it into let's see, we have foldable over here. We have the type class. It doesn't have anything to do with type class, so we're just going to put it in here. And if you look at these ones, you know, the foldable.type class and this one, they look exactly the same. Right? They look pretty much the same, but the first one was enforcing type classes, and the second one doesn't. So it turns out that if we hold on, did I not save? Okay, now I save it, it actually works. So it turns out that if you actually remove our type classes, right? So if I remove pretty much this entire thing like this, I think we don't need, I'm going to comment it out, I'm a bit afraid, but I don't think that we need them, right? So if I have, which one is this? This is the new one. This is the old type class instance. So if I just remove them, and if we're going to go to foldable factor, we're going to go to flat now, and we're going to say, hey, we don't need this weird type class. All we need is the same thing over here. Is the same thing like that. So if we have this instance, then we can do instance dot, well, it's not a dot, it's called apply now, right? So all it needs is, so we were passing current before, but now we need to pass a function of current, right? Function of current, because we're using flatmap over here, right? And that thing is going to have a fold. It will take the ACC and produce an add like this. I removed a bit too much. We still need the F. Still need the F over here, like that. And I copy paste it too much. So we have this f, and we need the instance that will take this f, okay, the f of result, and it will convert it to foldable of result, right? So this is the instance that we need, and this is the instance that we defined over there in foldable, right? So this instance works for flat map and it works for flatten. All right, so let me remove these other instances now, and in fact, we're not even using simulacrum. It's kind of funny. Okay, so let me just remove all of that stuff. Okay, so we have only this one tiny instance, and let's go to our flatten test and try it the other way around. So let's do that and do that, like that. So we're gonna have a list over here. We're gonna have sets over here, and we're gonna have a list over here. Notice what's happening here. We're calling flatten not on our collections library, right? So we're not calling this flatten over here, right? So what it turns out is that in the standard collections library, flatten is defined pretty much exactly like that. Instead, it's just that instead of foldable, it wants a gen traversable one. So it's already ready for basically for type classes, but it's basically ready for these views. And as you have seen, like a view is basically a multi-parameter type class. Okay, so what we can do is we can just go and define an instance which goes the other way around. Okay, so let's just do that. So let me copy this entire thing. Okay, I'm gonna have it over here. It's gonna be view from foldable to traversable. Okay, so foldable comes in, traversable comes out, traversable comes out. Okay, so it's going to be a new traversable. And by the way, this is the reason why I use traversable and not gen traversable ones. Gen traversable ones has like 50 methods that we need to implement, but traversable has only one, and it's called for each. It's not called fold. Final override def for each, and pretty much looks the same as our for each. Okay, so just a function comes in, element to result. Okay, unit, and as we have seen, a fold can actually implement that, but ours also have a for each, so we're just going to use for each. Right, so our foldable also has a for each, right? So this is just a delegation like this, and now everything should work again. Now let me actually show you something. If we go to the Scala Standard Collections library and we go to lists, so I'm in list, immutable list, okay? Then if I look for flatten, by the way, this is one thing that you need to know about Scala docs, that if you click on the signature, then at the very bottom there's a button called full signature. So this one is just for beginners, but you're not beginners anymore. So if you click on full signature, you will actually see that this is how flatten is defined. It's exactly defined as our thing. So it just wants some view from A to gen traversable once, and it is implicit. I'm showing you this because I want to show you flat map as well. So if we go to flat map, same thing. If we click on that at the very bottom, we're going to say show me the full signature. And notice that there's an implicit for something called can build from. We're going to talk about this some other time, but there is no implicit for this view. Now, how does it work? So our flat map looks different. Remember, our flat map, it has, where is it? Foldable factory. Our flat map, it has an implicit, it wants an implicit view like this, right? It's actually called view. Let's start calling it view. Okay, but in the standard collections library, it is not implicit, right? It's just a function. So does that mean that it's not going to work if we flip our chessboard example? Where is it? Chessboard example, okay. So let's say that these are not, okay, no, this is the one with the map, hold up. Let's say that these ones are not sets. Let's say that this is a list and this one is a set, and we need to be careful when to say that this is going to be a set from our homegrown collections library like this, and let's see if it's going to work. And somehow it works, even though it's not marked as implicit over here. So it doesn't use this type class encoding for views, but it still somehow works. What is happening here, flatmap says, hey, I want a function that converts my elements into a gen traversable ones of B. So what is happening over here is that what is being produced here is a set, and the set can be converted into a traversable because we have over here an implicit instance where we say that any foldable can be converted into traversable. Set is a foldable, so it can be converted into traversable. Okay, so this is what's happening here. So the type of this should be traversable, traversable of, let's see, it's a tuple of char and int like this, right? So the compiler is able to figure this out on its own and convert this convert this foldable into a traversable. Okay, so in fact, I can do a foldable over here probably like this. Right, it doesn't really matter. It's going to take this foldable, convert it into traversable. You can also do set. Right, like this. Okay, so we have proof that this is actually what happened. Okay, only a few things are left for me to show you, and the first one is that let me go to foldable factory. Flat map can actually be defined as a combination of map and flatten. Okay, so instead of this entire implementation, we can just say map to function. Come on, map to function, and then flatten like this. Okay. So this is exactly the same code. So every time you see somebody writing something like this, map to some function and dot flatten, just replace it with flat map. Okay, we're not gonna leave this one because this one is a bit more performant, and this is exactly why you should use flat map instead of mapping first and then do flatten. The last thing that I'm going to show you, that even though our flat map now all of a sudden has this very complicated signature, for comprehensions are very flexible. So for comprehensions are still super fine with that. So in fact, to show you this, I'm going to go to do we have it? No, we don't have it. Let me revert this back to this way around because I want to show you that flat map works, right? So we need this as a set and this one as a list like this. Okay, so now if I duplicate this line over here, and I'm going to comment this out, and I'm going to use a for comprehension now instead. Okay, so I'm going to say for, and let's see, we need the C from the characters, and we need the N from the numbers, and we need to yield C to N, right? So the for comprehension is still happy to convert this, very complicated signature into the for comprehension and the other way around, which is really cool. The last thing that I'm going to show you is that remember that we have the wrapper and we also have the foldable factory too. So we need to improve their type signatures as well. But I'm going to do this off the camera, so I'm just going to start doing this now, and I'm either going to spit it up or just cut it out. All right, so I did all of that, and this is the foldable factory too, and it looks like freaking crazy. You can check all of it out because I'm going to commit everything to GitHub as we always do. Just going to add everything, commit -am, and this is going to be video 25, and I'm going to call it I don't know, type classes. Let's call it views are type classes. No, let's call it our views type classes. Have some sort of mystery there. All right, let me push that. There we go, like that. Okay, it's been pushed. Let's check it out. Let's refresh. Okay, our views type classes. Let's see. Change the Scala version. Auto server disable the false. We're using simulacrum now. Different SPT version. We created a companion object for foldable. Was the instances for the views. We changed flat map. Changed flatten. Well, we added flatten actually. Did the same thing over here in the wrapper. Did the same thing in the foldable factory too. Added a bunch of tests for these sets, and that is pretty much it. All right, the last words for this video. I know that type classes sound really awesome, and you want to go and get your hands dirty with them, but always use the right tool for the job. Look at what happened when I tried, and well, it basically didn't go anywhere, and the much simpler solution actually worked. Was two implicit conversions, which are usually frowned upon, but in this case, this is exactly what they were designed for. And yeah, that's all I got for you today. Don't forget to like this video if you did, subscribe if you want to improve the developer inside you, and most importantly, take care.